Hi everybody, welcome to section 11.2. Okay, so you should have already done 11.1, watched the video, taken the notes, and done homework number 36. So in order to do this section, you should have the following in front of you. You should have your notes from 11.1 and 11.2, your computer with the video for 11.2, homework number 37, your Chapter 11 theorem sheet, and your Chapter 11 vocabulary sheet. You should get used to having all of these things with you. Put them together in a packet or whatever in your binder or wherever you store things, and keep them together because you're going to want to be pulling them out at least every day as we go through Chapter 11. So you'll need the notes for 11.1 because 11.2 builds on 11.1, and you may need to go back and refresh your memory, particularly when you're doing the homework. Okay? So very important stuff. Okay, Chapter 11 is about measuring the length and area of different shapes. And we did that in the first section, and then this section is about measuring the areas of trapezoids, rhombuses or rhombi, and kites. You already know a little bit about rhombuses, but trapezoids and kites are going to be kind of new. We're going to have 3 new theorems, and these will give you the formulas for the areas of these shapes. So this is why you need to have your theorem sheet handy, because these 3 theorems will obviously be on it. And yes, you will be able to use that in a quiz or the chapter test. Okay, so let's talk about trapezoids. Okay, what is a trapezoid and how do you find its area? Okay, a trapezoid has one pair of opposite sides, okay, called the bases, and they are parallel. Okay, and remember that a parallelogram has 2 pairs of opposite sides that are parallel. Okay, so they're similar in that they have 2 lines that are parallel, okay, but the rhombus has actually another set of lines that are parallel, but a trapezoid does not. These 2 lines are not parallel. So that's what makes a trapezoid. So in order to find the area of a trapezoid, it's really simple. You just take 1/2 times the height, which is right there, and times, okay, the addition of one base plus the other base. Okay, and here you can see the formula written below. It's really pretty easy, but as always, you'll probably have to go figure out what some of those values are before you actually get to figure the areas. Okay, so that's your first formula for this section, Theorem 11.4, area of a trapezoid. Okay, here we're going to do a little example. So again, our formula, 1/2 the height times the base, first base plus the second base. So here we have a international basketball court, which is not like ours, but it's close enough for this purpose. So let's identify our variables. So here's our height. Okay, so our height is going to be 5.8 meters. We'll call this B1. So B1 is 6 meters plus B2 is 3.6 meters. Okay, notice this is a plus sign, it's not a multiply. So we do what's inside the parentheses first. So we have 5.8 meters times 6 plus 3.6 is equal to 9.6 meters. Okay, we're going to multiply this whole shebang together. And I have this worked out if I can move the cat. Okay, and 1/2 times 5.8 meters. Is that 5.8 or 5? Yeah, 5.8. Whoops, I made a mistake. Okay, so I'm gonna have to calculate it out. Give me a second. Okay, 5.8 times 9.6 equals 1/2, 55.68 divided by 2 equals 27.84 meters squared. Okay, so you have these 2 meters here, and you're multiplying them together, and so that ends up with meters squared. And meters squared tells everybody that you're giving them area. Okay, so let's see what we got next. Okay, here we have, change colors just for, okay, vocabulary. The formulas for the areas of kites and rhombi or rhombuses use the lengths of the diagonals. So first we need to be really clear about what the diagonals are in a kite and also a rhombus. Okay, so here, and this is straight off your vocabulary sheet. So here's a kite. It looks just like a kite that you fly in the sky, or a simple one. Nowadays they have really fancy ones. But these are the diagonals. So it's kind of like where the wood sticks go on a kite. So one goes across the short side and one does the long length. Okay, so those are called the diagonals of the kite. So a rhombus, okay, kind of makes sense. Here's one diagonal and here's the other. Okay, so those are the diagonals of a kite and a rhombus. So make sure you know what those are. So here comes another formula, another theorem, theorem 11.5, area of a rhombus, okay, is 1/2 diagonal 1 times diagonal 2. And conveniently, theorem 11.6, the area of a kite, is the same thing. Okay, area equals 1/2 d1 d2. Okay, so you really, even though you got 2 theorems, you only have to remember one formula. So 1/2 d1 d2. Okay, so let's try some. So this first figure here, I want to talk to you about because you're going to see a lot of these. And these are very classic questions on quizzes and tests. Let me get my notes here so I remember to tell you everything I'm going to tell you. So you see a figure like this, and you start going through your list of figures, and you say, well, okay, we're talking about this guy right here. It's not a kite. It's not a rhombus, okay, because this side here is not parallel to this side. Okay, it is not a square, obviously. It's not a rectangle because you got this diagonal here. Okay, it's obviously not a triangle, and it's not a parallelogram because you don't have, these 2 sides aren't parallel. So what do? So you could argue that it's a trapezoid, but then in order to find the area, you'd have to, you have to find these 2 diagonals, and that would be really tough, and you don't want to do that. So whenever you have a problem where the figure is not one that you have a formula for, the only choice you have at this point is to divide it up into figures that you have formula for. So all we have to do is do a little divide here. So think divide and conquer, okay? So this divides this figure into a triangle and a rectangle, both of which you know the formulas for. So let's work out the triangle first. So you know this base up here is 6 feet and this is 8 feet. So if you subtract 6 from 8, you know that this little base right there is 2. Okay? And then these two are parallel, so you know that that height is equal to 4. So for our triangle, okay, our formula is 1/2 the base times the height equals 1/2 2 times 4 is going to equal 4. So the area of this triangle piece right here is 4. Okay, now let's do the rectangle piece. Okay, and our rectangle, the formula for area is base times height. Okay, we have a base of 6 feet and a height of 4 feet. Okay, equals 24. So this area is 24. But you're supposed to find the area of the figure. So what do you need to do? You need to add the pieces together. 4 plus 24 equals 28. Don't forget this last step, okay? Because if you gave me 4 or 24 as an answer, I would not be able to give you credit, okay? Because you didn't answer the question. So please make sure you answer the questions and add those two pieces together after you cut them up. Okay, that's really the only challenge in doing that. Okay, let's look at number 2. Number 2 is a kite, obviously. Okay, and the area of a kite is equal to 1/2 diameter 1 times diameter 2. Area equals 1/2. Okay, let's find our diameter. So we have 1 there, so we'll call that D1. So that's 6. Now we need this long one. And they didn't put the number inside the kite, they put it outside the kite, so that's 14. Okay, so the area is equal to 6 times 7 equals 42. Okay, 42 inches squared. Okay. Now, let's do the last one. So, what is this thing? Number 3. Okay, it's a parallelogram, possibly. Okay, and it has 4 equal sides. So remember, a parallelogram does not have to have 4 equal sides. But this does, because that's what the red lines tell us, right? So it's a parallelogram with 4 equal sides. And so that is a rhombus. Okay, 4 equal sides and 2 sets of parallel lines. Okay, it's not a trapezoid because both sets of lines, both pairs of lines are parallel. Okay, so it's a rhombus. So we're being told, well, the area for a rhombus is the same as a kite. It's 1/2 D1 times D2 equals 1/2. Okay, here's our diameters. Here's 1 diameter, so that's 30. The other diameter is 40. 30 times 40 is 1,200. Area equals 600 meters squared. Okay, so that's really all there is to it. This is kind of a really short little introduction, and I'm sure you're going to be able to do the homework and finish up 11.2. Next, you'll have a quiz on 11.1 and 11.2, but before you do that, homework number 38 is the review for sections 11.1 and 11.2. So after you finish the homework for this section, you need to do your review, and then you need to take the quiz. Okay,